if I said, I don't know, if I said you have 7 fish, and then I say we keep 100% of the fish, how many fish do we have?
7 fish.
7, not rocket science, right? Okay. So, in this little bracket here, we have 1 plus I, and we have 1 minus I, and that's the base of the exponent. And we talked about this. We said if b was greater than 1, we had a growing exponential function. Remember? We talked about the graphs. And if b was between 0 and 1, we had an exponential decay function. So what we're doing here is we're doing 1 plus I, 1 minus I. 100%, what is that as a decimal? That's just 1 as a decimal, right? We agree? Do you see this 1 here? That's just 100% as a decimal. That's why they have a 1 there. Okay? If I'm increasing by 2.4%, would I use 2.4 in that formula? No, I would use 2.4 divided by 100, which is 0.024. And a lot of people will tell me 24. It's not, that's 24%, right? 0.024. So if I'm increasing, I would add, let's say I was increasing by 5%. I would go 1 plus 0.05, which would be 1.05, correct? If I was decreasing by 5%, I would end up with a b value of 0.95. So if it's above 1, I'm increasing, correct? If it's below 1, I'm decreasing. You see that? How much I'm increasing or decreasing is how far away I am from 1. So how far away is this one from 1? 5. So 0.05, so be 5%. How far is this one away from 1? 0.05. So I'd be decreasing by 0.05 or 5%, right? So that's all it is. It's nothing crazy. F here stands for the final amount. Capital I stands for the initial amount. Little I is the interest rate. But what does it have to be in? In decimal form. Because you're adding it to 1, which is 100% in decimal form. What do you suspect n might be? Sorry? Yeah.
Number of time.
Yeah, so number, it's always, this one's always number of years.
Does it have to be years, or will it be, could it ever be?
We deal with years for these formulas. Now remember in exponentials, sorry, not exponentials, in geometric in grade 11, if it gave you 2000 to 2005, you would go 2005 minus 2001, and you add 1 and do all this random stuff, because the formula was n minus 1. That was the exponent. It was n minus 1, right? Is this exponent n minus 1? No, it's n. So how do you get the years? You subtract them. That's it. So if it's 2005 to 2000, it's 5 years. There's no overthinking, no adding 1 to take 1 off because term 1 is actually term 0 and blah, blah, blah. None of that. Just subtract the years. So let's look at this question. It says the initial price of the car is $30,000. So what letter variable does that give me? Yeah, capital I is 30,000. And we always state our knowns, just like you do in physics, chemistry. The value of the car depreciates. So what does that tell me? I'm going to have to use the minus formula. I'm going to go 1 minus. Now, I don't really need to know the formula or memorize the formula. I just need to know why the formula is the way it is so I know to plug it in, right? Understanding so much. And it's 20% per year. They sometimes write per annum. Per annum just means per year. Don't let it throw you off. That's what they'll write. Or per A. So what does that give me? Little I. And what is little I going to be? 0.2. 0 if you so choose. so that you can see that it's actually a 20. Okay? If the car is new in 2005, how much will it be worth? So what are they asking me to find? F, the final. In 2010, what did they give me? What is that? N. So then let's fill it in. We get F equals 30,000, bracket 1 minus 0.20 to the 5, which if we want, we can say 30,000, bracket 0.80 to the 5. Now I want everyone to type it in because I want to see if you type it in, if you can get the correct answer. Because just because someone else beside you can type it in and gets the right answer doesn't mean you can. So make sure you're getting $9,830.40. Where's 30,000? For the one. All right, and then we need a sentence. The car will be worth $9,830.40 in 2010. Make sure you have all of your statements so they know what you found.
I always use marks, not any sentence.
When you subtracted 0.8, you're not taking it all that's on the board. Really? You did like a mix of step 1 and a mix of step 2.
Why are you saying huh? I didn't say anything.
All right. The next one says, how long will it take? So what are they making me find? N to the nearest tenth of a year, so I know that's 1 decimal place. For the car to be worth half of its original. So what's its original? Its initial, so 30,000. Half of its original, what did they give me? Yeah, is the final. Did the interest rate change at all? No. So let's fill in what we know. 15,000 equals 30,000 bracket 1 minus 0.20 to the n. Now, if you do this every time, you'll be in good form. If you have the final and the initial, if you have both, the final and the initial, you always divide your initial over as your next step. Every single time. So whenever I have the final and the initial, I divide it over. And I get 0.5 equals 0.8 to the n. Bless you. Now, if I'm missing F, you guys can solve for it. You have all the math skills. If I'm missing capital I, you can solve for it. You have all the math skills. If I'm missing little I, you can solve for it. You have all the math skills. You just have to do square roots and stuff like that, or eighth roots. If you're missing the variable in the exponent, you don't actually have the math yet to solve this algebraically, unless you can make common base, which I can't make 0.5 and 0.8 in common base. So the key thing here is, if your variable is in the exponent, to solve it algebraically, you have to convert it to a logarithm. So logs and exponentials actually work together. Even though they're separate units in the textbook, you kind of can't test on one, because you need each of them. To solve an exponential, you need to convert to a log. To solve a log, you need to be able to convert to an exponential. So you need each of them. So how do I convert this to a log? Everyone paying attention? Because conversions are very easy if you're paying attention. What is the base of this exponential? The 1 isn't even a number on here. Yeah, 0.8 is the base of my exponential. You agree? Are you saying like the original equation?
No, I thought it was like over. What is it over?
Oh. Ah, gotcha. Like denominator.
Yeah.
So the base of my exponential is 0.8, right? It's the base to the exponent. If you remember that the base of the exponent becomes the base of your log, you'll be able to do the conversion very easily. So what am I going to do? I'm going to write out log. I'm going to write the word log. And the base of the log is a subscript to the word log. So right below log here, I'm going to have 0.8. Do you see how it's the word log and then below that is 0.8? I'm trying to show the proper way to write this because after this I'll walk around and you guys will have stuff all weird and all over the place. Can't do that. So the base has to be below the word log. Everyone has that? Then beside it, there has to always be something beside the log in brackets. And it is at the same height as log. Like if I drew an imaginary line under the word log and under that bracket, it would have the line go straight along. So log and the bracket are the same height. Do you agree? So if I was doing this on a lined piece of paper, log and the bracket would be the same, and I have a little subscript in the line below. Right? Okay. Now, when I convert to another form, if I kept the same stuff together, would you really be converting? Like if I went 0.8 and n, would I actually be doing anything? No, I'd be rewriting what I have. So the key thing to being able to convert is to make sure that the base of your exponent becomes the base of your log, and then what's with it or what's friends doesn't stay friends. So what's currently with 0.8? N. So when I convert it, n isn't going to stay with it. What's going to be beside it now? 0.5. And it always equals the exponent. So do you see how I got that n down so I can solve for it now? It always equals that exponent. That's why we convert to a log. Now how do we type these in? I'm going to show you the way that everyone can type it in. And then I'm going to show you the way that the fancy calculators can type it in. So the way you have to type it in, if you have the older calculators, or any of them, so you can all follow along and do it this way, is you can go log 0.5. When you press this is log base 10. It doesn't have the option to drop a base down there. So you'd go log 0.5, which is your top log, like the top word. And then you divide it by log of the base, log 0.8. And we get 3.1. Everyone's calculators can do it that way. Now, if you have the calculators where the exponent pops up, your life is exponentially better. There's a button that gives you the log. So press math. If you have a TI-83, it ain't happening. Press math, arrow up. You could arrow down, it's just going to take you a while. Arrow up, and it's A. And you can just type it in the way it looks. And it's 3.1. Okay? Yeah, I was like, he's got the button.
That's the old calculator look like I thought.
Ask Lucas. N equals 3.1 years. So it says, how long will it take for the car to be worth half of its original? It will take 3.1 years for the car to be worth half of its original value. Now, I have found out over my 18 years that you guys think that I write stuff for fun, and then you just put it takes 3.1 years and call it a day. If I write something, once again, it's because it's the way to get full marks. It takes 3.1 years. What's it, and what's it taking 3.1 years to do what? Like if I can ask you what's it, and you'd be like, well, obviously, it's a car. Cool. And what's it doing? Well, 3.1 years. Well, what's it doing? Oh, it's halving. If you don't have any of that, you've explained nothing. You've just said it takes 3.1 years. What? Orange to grow? Like what is taking this 3.1 years? So you have to say, if you say it, you have to clarify later what it is. It will take 3.1 years for the car to be worth half of its original value. Now, can I ask any questions? No. What's it? It's a car. What's it doing? It's becoming half its original value. It's all answered. It's all stated. No one can take a mark off of you. You've literally told them exactly everything. And you're just restating the question. These are the best sentences ever because I can do them. Okay. Now, side note. I want you to type this into your calculator. Log base 2 of 8. However you have to do it. So you can go log 8 divided by log 2. Or you can type it into your math part. So log 8 divided by log 2.
3.
So it's 3. Okay, try this one. Log base 3 of 27.
Oh, man, I'm too good.
What about log base 2 of 32? It's 5. Okay, what about this? Log base 1/2 of 4. It is -2. So, what is your calculator doing every time it's logging? Yeah? Nope. Let's look at these. Log base 2 of 8 equals 3. Log base 3 of 27 equals 3. Log base 2 of 32 equals 5. Nope. Nope. It's saying the base to what exponent equals what's beside the log. So 2 to what exponent is 8? 3. 3 to what exponent is 27? 3. 2 to what exponent is 32? 5. A half to what exponent is 4? A half to -2 is 4. Because if I have a negative exponent, I can flip these 2 over 1 to a positive exponent, and I get 4, right? So it's the base to what exponent gives me that. Now, some of them aren't as easy. Like, what if I give you this? You type this in. Log base 2 of 5. .3 something, 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 right? And I could have gotten close to that. Now, why could I get close to 2.3 something, something, something? Because I can figure out numbers that I can actually get values to that are on both sides of 5. So if I go log base 2 of 4, which is right on the other side of 5, I get 2, because 2 squared is 4. And then the next one would be log base 2 of 8, which is 3. Well, 5 is closer to 4 than to 3, so I know it's going to be 2 point some lower decimal, right? So you can reason as to what it is. So that's it. Every single time you're typing in a log, that's all your calculator's doing. Base to what exponent equals what's beside it. That's it. All right. So let's go back here. Let's try this one out. So the population of the city was 250,000 on January 2000, January 1st, 2000. Now, some people don't know if it's initial or final. I have to keep reading because until I read, I don't know either. And then it was 310,000 on January 1st, 2008. So which one is the initial? 250,000 because that was in 2000. And what's the final? 310,000. What else did I get from that? N is 8. Then it says, if the growth rate of the city can be modeled by an exponential function, the average annual growth rate of the population to the nearest tenth of a percent. So what's it asking me to find? Little I. So we have final, which is 310, equals initial, which is 250,000. Bracket 1 plus I, don't know what it is, to the 8. And what did I tell you you should first do if you have final and initial? Divide them. Now I'm never going to do decimals. I'm going to keep all my stuff because I can only round to the very last divide. How do I get rid of an 8? Now some people are like, I have to convert to a log. Is the exponent in the is the variable in the exponent? No, you do not have to convert to a log. Actually, do not convert to a log. You have to take this 8th root of both, and I leave it like that. I don't even turn it to a decimal. I write the 8th root of it. So now I have the 8th root of 31 over 25 equals 1 plus I. And then what do I have to do? Subtract 1. And I equals something. So I'm going to type that all in. I'm going to go the 8th root. So I go 8 math number 5. The 8th root of 31 divided by 25. If you do not have the function where the square root runs along the top, you have to put 31 divided by 25 in brackets, right? Because it'll go 8th root and then it'll open a bracket. You have to go 31 divided by 25, close the bracket, and then subtract 1. Now I have to times it by 100. It wants the nearest 10%. So I is 0.02725. When I times that by 100, I get 2.7%. And then you have to write a sentence. The average annual growth rate of the population of the city is 2.7% from the year 2000 to January 1st, 2000 to January 1st, 2008. Okay, so you have to write all of that out. Now, do you see example 3? You also see, when I flip the page, if it lets me flip the page, example 4. I want you to do those, 3 and 4. Try them out. This one says, in 2002, the population of the city was 160,000, and it's increasing at a rate of 4.5%. Should say percentage or something. Okay. To write an equation to represent the population P of the city as a function of time N. So we can't go F equals here if they tell us that it has to be P. So make sure that you use P equals initial, which is 160,000, bracket 1 plus 0.045 to the N. So technically it would be P equals 160,000 1.045 to the N. Okay, then it wants the population in 2005. So how many years later is that? Don't all answer at once. 3. So we go 1.045 to the 3 times 160,000. Wow, I did not do that. 182, 586. Did you round up or down?
Sorry, 587.
No, you'd round down. Yeah, why would we round the population down? In the year 2005, they had 182, 586 point something, correct? So in the year 2005, when I cut it off, how many people do I have? Whole people. 182,586. The next day, I might have 587. Cool. But in the year 2005, when I do the cutoff, I can't find a random point whatever of a person to make that whole person. Okay? It's the same thing. This is likened to if I was shoving cows in a trailer. Okay? And I say, here's the trailer, get in cows, and they're like, and they jump in, and they're in, and they're in, and the trailer fits 7.8 cows. Cool. So that's obviously 8 cows that it fits. No, you'd have a cow's butt hanging out of the back of the trailer, or the door wouldn't close. Correct? So even though it fits 7.8 cows, that's cool. How many whole cows does it fit? 7. You can't cut the butt of the cow off and then shove it in. It's dead. That's what's happening to the cow. You can't have its butt hanging out. The full door closes on a trailer, right? All the cows would fall out. You would just kill all the cows now because you want to fit 8 into a 7.8 trailer. Okay? So only 7 full cows fit. The year 2005, we have 182,586 real people, like full people. Okay? All right. Here, why? Okay. So it says, if the population continues to grow at this rate, determine the number of years for the population to double. So now we're at 320,000 equals 160,000. Bracket 1.045 to the n. And once again, I'm missing the exponent, so I know I'm going to have to convert. But because I have final and initial, the very first thing I'm going to do is divide them. So I get 2 equals 1.045 to the n. And the moment I don't know my exponent, I'm converting to a log. So I get log base what? What's the base of my exponent? 1.045. What goes beside the log? 2. And then it equals n. Right? So what's friends doesn't stay friends. It always equals the exponent, which it should. That's how we get the exponent from down. Right? When we type that in, .045, not 1.145. Oh my goodness. It's 15 point, and it wants nearest year. So n would equal 16 years. So once again, we would write a sentence. If the population continues to grow at that rate, it will take 16 years for the population to double from the year 2002. Explain the whole thing, right? Be thorough. Okay, the next one is the number of fish in a lake is decreasing by 5%. So I know my little I is 0.0405, and I know I'm doing 1 minus I, not because I memorized the formulas, not because I wrote down the formula and I can fill it in. I know it's 1 minus the interest rate because it's decreasing. 1 is 100%, and I'm taking it down 5%, so I'm going to have 0.95% left, or 0.95 in decimal form left. I don't need to memorize the formula, understand. And it's as a result of overfishing. Write an equation to represent the number of fish present in T years, so now I have to use a T instead of N. Use NO to represent the initial population and NT to represent the final. So I have N of T equals NO 1 minus 0.05 to the T. I don't have choices. I have to say do what they say. So I have N of T equals N sub O of 0.95 to the T, which makes sense because it's decreasing by 5%, that I would have 95% of all the population left every year. Now here it says if there were 22,500 fish present in January 2000, how many would you expect in 2005? So this is NO, my initial. What else did they give me? And January to January is easy. So T equals 5. And they're making us find N of T. So N of 5, technically, equals 2,500, 0.95 to the 5. Now, should I have more than 2,500 or less than 2,500? Why? It's decreasing. It's below 1, right? Yeah, 1,934 fish. So I would say, it says, how many would you expect to be present in, what is, I would say, in January 2005, there will be 1,934 fish present. Then it says, how many years, it should be an S, how many years to the nearest tenth? So it wants us to find T. To the nearest tenth means one decimal place, so I want to make sure that I don't forget that. And round to the nearest whole number. Or something. What did it take for the fish population to reduce to half the number? So what's my final amount going to be? Yeah. So I'm going to get 1,250 equals 2,500. 0.95 to the T. I have my initial and my final, so I have to divide. So I get 0.5 equals 0.95 to the T. And once again, I am missing the exponent. The exponent is where my variable is. So I know I'm going to have to do what? Log it. Convert it to a log. So I'm going to get log base what? What's the base of my exponent?
0.95.
0.95. So I get log 0.95. What goes beside it? What's currently with it? T. So what goes beside it now? 0.5. Because what's friends doesn't stay friends. And then equals T. 13.5. Okay, B. So when you write a sentence, you're going to say that it would take 13.5 years for the fish population to reduce to half of the number in January 2000. Like, I rocket these sentences because you literally just rewrite it. So, yeah. Okay, we're looking at the half-life doubling, tripling, and then tomorrow we're looking at compound interest formulas. And then we're actually done exponentials and we're moving on to logs on Monday.
You just like making life hard.
Logs on Monday.
Jesus.
It's our savior. Thursday is a half day.
Is it?
There's teacher interviews.
Honestly,
Friday is off
Is Friday off?
because of parent-teacher interviews.
What?
Am I the only one who?
Oh, no, tomorrow's my birthday. What are you getting me?
On
Oh,
Monday.
it's your birthday tomorrow?
You want to make me cookies?
Sure.
Actually?
Not really.
Put glass in it.
Maybe I'll make you cookies. Then I'll start your present. And I'll have to like bring everyone
No, you don't.
for their birthday.
I'm your favorite student.
All right.
It's a good idea. Is that actually good?
Okay, so here I should be an R. That was a typo. Okay, so here, half-life doubling, tripling. So it's an R because that was 1 plus an interest rate or 1 minus an interest rate in the previous one, correct? Now it's just an R because let's think about it. If I say that something is doubling, what is something doing if it has an increase or decrease? What percentage is it at? 100%. If it hasn't increased or decreased, it's at 100%, correct? If I had 7 fish and I take 100% of 7 fish, I get 7 fish. Didn't increase, right? So if I tell you that the interest doubles, what would you tell me the rate is now? 200%, or what in decimal form? 2. What if it triples? 300%, and what would that be? 3, because I'm timesing by it, technically, right? I'm multiplying. I'm no longer 1 plus something or 1 minus something, I'm multiplying. So that's why it becomes an R. So if I'm doubling, I go from 100% to 200%, and in decimal form, R would be 2. If I'm tripling, I go from 100% to 300%, and my R would be 3. And if I'm halving, or have a half-life, what's half of 100? 50. And what would that be in? 0.5. Or you could use a half, technically. My F is still final amount. My I is still initial amount. If you have radioactive material, it has half-life.
She's trying to be cultured.
So, we have T over P as our exponent. Do you see that? So that is a T and a P. They mean different things. So T and P are where people get hung up. T is time to reach final. So I draw the arrow on the top because it's time to reach final. So if it's like in 10 years I have 4,000 bacteria, then it would go there. Time to reach final. Whereas P is the period. And we know that the period is how long it takes to repeat itself. On a graph, that's the period. And then here, that's the period. It's how long it takes to repeat itself. So if it says that it doubles every 4 days, the P would be 4. Because every 4 days it's doubling, and then in 4 days it's doubling again, and 4 days it's doubling. If it says the half-life is 6 hours, then that would be my P. 6 hours, it's halving, and then the next 6 hours it's going to half, and the next 6 hours it's going to half. Whereas T is time to reach final. In 10 years, I have 4,000 bacteria. Okay? So P is the half-life doubling or tripling period. It often follows the word doubling, tripling, or half-life. It doubles every 10 hours. It triples every 3 minutes. It halves every 4 hours. Okay? So let's see if we can decipher through what we have here and what we need. So here we have a lab tech placed a bacterial cell. What does that mean?
1.
What is 1?
Single.
That's the definition of 1, but what letter is 1?
Oh. I.
Yeah. So I is 1 into a vial at 5 a.m. The cell divides in such a way that the number of cells doubles every 4 minutes. What did that give me? So R is 2 because I went from 100% to 200%. And then T or P? It doubles every 4 minutes. So it's the period, right? In 4 minutes it will double. In 4 minutes it will double. In 4 minutes it will double. So that's the period. T is time to reach the final amount, whatever the final amount may be. Okay. Here it says, how long does it take for the cells to divide to produce 4,096? So what did it give me? And it asked me for the time to reach final, which is T. So I'm going to be missing an exponent, and when I'm missing an exponent, I can log. So I'm going to get 4,096 equals 1 bracket 2 to the T over 4. Now when I have initial and final, I told you to divide that initial over first. It's not going to do anything because it's a 1, but that's okay. 4,096 equals 2, and I don't like writing it, I write it slanted, but it's better if you don't write it slanted, because if you write it one over top of the other, you'll see more so that that's a division of 4, and to get rid of the division of 4, you multiply by 4, but when slash, people don't often see it as well. Now, I am missing an equal sign, but besides that, my equation, the exponent is in, or the variable is in the exponent, so I know when the variable is in the exponent, I have to do what? Convert to log every time. So I'm going to get log base what? What's the base of my exponent? 2. So I'm going to get log base 2. Then what goes at the exact same height as the log? 4,096. And it's going to equal the exponent every single time. T over 4. Right? Because what spreads doesn't stay friends when I convert. So 2 to what power is 4,096? 12. So when you type log base 2 of 4,096 in your calculator, that's why you get 12. Because 2 to the 12 is 4,096. So I get 12 equals T over 4. And if I write it like this, there's a much bigger chance that people will realize they need to multiply by 4. So I get T equals 48 what? Minutes, because T and P have to be in the same units. And then when I would write my sentence, it would say, how long does it take for the cells to divide to produce 4,090 cells? It takes 48 minutes for the cells to divide to produce 4,096 cells. The next one I'm just going to start because people get stuck on this one because I don't actually give an initial value. So this one here says, what is the half-life? Where does that go in for? R is a half. Or I could put 0.5. Of plutonium-232. 232 doesn't appear anywhere in your question. That's an isotope. It's lovely. It's great. The number doesn't appear anywhere. Plutonium-232. If in 204 minutes a sample decayed to 1/64th of its original value, it wants what is the half-life? So it's asking for P. If the question contains half-life, doubling or tripling, it's asking for P. What is the half-life? So how long does it take to have? 204 is what? P. Now it says that it decays to 1/64th its original. That's not F technically. It's 1/64th its original. You should say, Mrs. Lepp, what's its original? If its original is 1, then its final is 1/64th. If its original is 100, then its final is 100 times 1/64, right? If its original is 5, then its final is 5 times 1/64. So what would be the best original to pick if you have a choice? Because we can pick whatever original we want. 1. So if my initial is 1, my final is going to be 1/64. As a side note, pay attention. So if I picked my initial to be 100, my final would be 100/64. Which is 100/64. And then I would have whatever to the whatever over whatever, correct? But my first thing that I have to do is divide by 100, which would get me 1/64 over here equals whatever to the T over P, correct? So does it matter what my initial is? Because the moment I divide it over, I'm going to get 1/64 as that final anyways. So your best choice to pick if you have an option, if it says it's whatever of the original, I always make my original be 1. Then my final is whatever the heck that is, right? So let's fill in our formula. So I have 1/64 equals 1 times 0.5 to the 204 over P. Divide by 1. And I get 1/64 equals 0.5 to the 204 over P. Am I allowed to round early? Or do I have to carry every decimal to the very last step? Carry every decimal. I'm allowed to round to my very last step, correct? Okay, once again, I have the exponent. It's locked in, the variable is locked in the exponent. So what do I have to do? Convert to a log. So I'm going to get log base what? Log base 0.5. And then what goes beside it? 1/64. And it equals 204 over P. So when we type that in, what do we get? 6. Now this is where the problem happens after this. People want to divide by 204 or something. I have this P down here. How do I get the P to come up? Times it by P. Now I have 6P equals 204. What do I do? 5 by 6. P equals 34 minutes. So what did I find now? Yeah, how long it takes to half, right? Period of the half-life, yeah. So I would say, what is the half-life of plutonium-232? The half-life of plutonium-232 is 34 minutes. You're going to flip over. There's example 3, 4, 5 on the back. 3, 4, 5, go. So we have a radioactive isotope has a half-life of 7 years. So I know R is 0.5. Is that T or P? P or P? 7. It's P because it follows right after the word half-life. A half-life of 7 years. So every 7 years it's halving and halving and halving. So that's the period. How much of the isotope will be initially present to decay to 60 grams in 14 years? Why do I keep reading all the S's? So I'm going to get 60 equals I bracket 0.5 to the T. What was the T? T is 14. 14 over 7. So I get 60 equals I. And then I get people trying to convert it to a log. Is the variable in the exponent? Is the variable in the exponent? No, there's a 2 in the exponent. So am I converting it to a log? No, I only convert to a log when the variable's in the exponent. It's being multiplied by I, so I divide it. $240 milligrams. No, grams. So you need to state that that 240 grams of isotope is initially present to decay to 60 grams in 14 years. Then we have a material. Did everything perfect? Don't need to check. Who is this guy? This guy wants cookies for his birthday, but puts all of his stuff away. A material. All right. So a material has an initial mass of 50 milligrams and a half-life of 20 minutes. So that's P. Follows right after the word half-life. Determine the mass after 35 minutes. So they want final. So I get final equals 50 bracket 0.5 to the 35 over 20. Do I have to convert this to a log?
No.
No, it's all on the right-hand side. Just type it into your calculator.
14.
So the final equals 14.9 milligrams. So the mass after 35 minutes will be 14.9 milligrams. Then this one says a culture starts at 3,000 bacteria. So that's my initial. After 3 hours, it's estimated to have 48,000. So that's time to final. That's T. What is the doubling period? So once again, I have to divide by 3,000. So I get 16 equals 2 to the 3 over P. Now guys, you can convert it to a log, but you also might be able to spot this. I can make them both be base 2. 16 is 2 to the 4. This is 2 to the 3 over P. Remember, if I make them the same base, I can set these equal. So I get 4 equals 3 over P. Swap them. And I get P equals 3 over 4 for 0.75 hours. So your answer would be the doubling period is 0.75 hours. And then this we're doing tomorrow. We have a short day. And then because it's period interviews, you get the day off after. Even though you're in grade 12 and have been in the school division for that many years. I didn't know that that's how it worked.
Tomorrow is